In class today, we solved this rational equation. I'm creating a video for it so that we can all have another chance to think through this together. So the first thing to notice is that x squared plus 3x minus 10 can be factored as x plus 5 multiplied by x minus 2. So I'm going to rewrite the right-hand side as 7 over x plus 5 multiplied by x minus 2. And now I want to get rid of the denominators, and I'm going to do that by multiplying both sides of the equation by x plus 5 multiplied by x minus 2. So let's start with the easier side. If I do this on the right, my factors of x plus 5 in the numerator and denominator cancel. My factors of x minus 2 in the numerator and denominator cancel, leaving me with 7. And then on the left, I'm going to distribute this product to 3x over x plus 5 and to 1 over x minus 2. And this gives me, I'm going to write this out carefully, x plus 5, x minus 2 multiplied by 3x all over x plus 5 plus x plus 5 multiplied by x minus 2 all over x minus 2. So I see that I have factors of x plus 5 canceling and factors of x minus 2 canceling, which gives me 3x multiplied by x minus 2 plus x plus 5 equaling 7. So now I see that I'm going to have a quadratic equation, so I'm going to simplify the left-hand side. This gives me 3x squared minus 6x plus x plus 5. So I'm going to combine like terms here to get 3x squared minus 5x, and then I'll subtract 7 from both sides. That'll give me 3x squared minus 5x minus 2 equals 0. So now at this stage of the game, I need to solve this quadratic equation. And there are multiple ways that I can do that. I can use the quadratic formula, or I can factor. So as requested, I'm going to solve this both ways, and I'll do that down here. So first, we're going to talk about factoring. And it's possible that you learned the AC method for factoring. If you would like to use that method, that's fine. I think it's more intuitive to think about an expansion box. So we know that we want two factors that multiply to give us a quadratic term of 3x squared and a constant of negative 2. So we know that this is going to be 3x and x, and then we know we need to have two numbers here and here that multiply to negative 2 and then give us linear terms that add to negative 5x. So there aren't that many possibilities to try here, so let's just try something and then adjust if needed. So here, negative 2 and 1 multiply to negative 2, but then negative 2x and 3x do not add to negative 5x. So what we can do is switch these. Now let's try this. This gives us x, negative 6x. Now if we add negative 6x and x, we get negative 5x, and then the quadratic term and the constant term are what we want. So this quadratic factors as 3x plus 1 multiplied by x minus 2, which means The solutions are negative 1/3 and 2. So we could also use the quadratic formula to do this. So we would say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is 5 plus or minus the square root of 25 plus 24 all over 6. So that's 5 plus or minus the square root of 49 over 6. So that's 5 plus or minus 7 over 6. So we get 12 over 6, which is 2, or negative 2 over 6, which is negative 1/3. So here are two different ways to find the possible solutions of this rational equation. But now, let's look at x equals 2. We see that the left-hand side and the right-hand side have an x minus 2 in the denominator, which means that both sides of the equation are undefined at 2. So what we want to write is x equals 2 is an extraneous solution because both sides of the equation are undefined at x equals 2. And then what we can do is look at negative 1/3 and if we plug negative 1/3 into both sides of this equation, we're going to see that we get a true statement. So what we're going to do here say this is a solution, and you can check by graphing or plugging. Just a second. X equals negative 1/3 into both sides. Remember that when you check by graphing, the intersection of the two graphs is going to tell you the solution. So you will see the graph of this side and the graph of this side intersecting at x equals negative 1/3. And just to reassure you, if the arithmetic is a little finicky, you will have some kind of calculator. If not a graphing calculator, you'll have a TI-30 calculator to use. And depending on the problem, you might also be able to use a graphing calculator to confirm that you have a solution. So that is number 7A.